Hello, my name is Naveed.
And my name is Ben.
And this will be a presentation on discriminating similar languages within the Weka toolkit.
Weka is a popular machine learning software. It has a huge collection of machine learning algorithms for data mining tasks. The process of machine learning can be extremely beneficial for computing complex tasks. The Weka toolkit offers various collection of tools for data pre-processing, such as classification, regression, clustering, association, and visualization. The aim of this experiment is to distinguish various Arabic dialects with the given R file. We have been tasked to find the best classifier for the Arabic text.
We applied a filter on the dataset that allowed us to structure and condense the data into something that is easier to visualize and measure, as well as remove any unnecessary data that is not related. The filter we used for this was the string to the word vector and the word tokenizer, which is an association rule. This allowed us to convert string attributes into a set of attributes representing word occurrences, using information from the text contained in the strings.
Weka has three main features: classify, cluster, and associate. In our case, we used the first feature, which was classify. The classifiers we used were 0R, naive Bayes, IBK, random tree, and J48. On all of the classifiers, we ran cross-validation.
We use cross-validation to run the classifier n amount of times, and each time it uses a different sample from the dataset. 10% of the data is used for testing, and the remaining is used for training. The process of choosing the best classifier was merely through trial and error. The results varied from each different classifier. We also used a test R file to see the accuracy of the results generated.
The next classifier we used was 0R. By using this classifier, the amount of incorrect results was 76%. We then used the test file provided, and the accuracy further decreased by 1%. The confusion matrix states that all of the instances were classified as Levantine dialect. This reflects the accuracy. It is safe to assume that this classifier is not particularly accurate.
Here, we used a naive Bayes classifier. The amount of correctly classified instances was 47%. Again, using the test file, the percentage of correctly classified instances decreased to a further 22%, and the incorrect increased to 77%. The confusion matrix shows many misclassifications. For example, 385 instances incorrectly classified as Egyptian when really it was Gulf. This classifier is also very inaccurate.
The next classifier we used was IBK. This was the most accurate classifier with a result of 97%. When comparing this confusion matrix to the one generated by naive Bayes, you can see the values becoming more concentrated. This is a good indication of the high level of correctly classified instances, and a few misclassified instances of each class in the dataset.
The random tree classifier generated positive results of 97%. The confusion matrix generated was exactly the same as the IBK classifier. It shows correct correlation and very few misclassified instances. The random tree visualization is hard to make sense of due to the sheer amount of data being shown overlapping each other.
The J48 classifier correctly classified the instances at 74%. The confusion matrix shows that the classification is scattered, but has done a good job of classifying the dialects into the correct group. Again, similar to the random tree, we're not able to make sense of the tree due to the amount of data. Finally, the reflections. The best classifier was IBK and random tree. They both gave the same results, given a total of above 95%. In some classifiers, the confusion matrix was quite difficult to decode. For example, naive Bayes. This could have been due to the amount of data. However, it is also proved to be useful in bringing down the classifier's accuracy for classifying each class in the dataset. Furthermore, can we assume that the results were entirely accurate? We could have used a different algorithm or a different feature to test the results against each other. Also, would adding or removing data change the accuracy rating?
The speed of processing the results was tedious and long. Some of the classifiers, especially the tree classifiers, took over 430 seconds to build the model. Choosing an appropriate classifier would have reduced the waiting time. Lastly, the tree visualizations were so messy that we were unable to take advantage and use this information to deduct which tree classifier followed the best path in classifying the data. Therefore, we were only able to use a summary, confusion matrix, and time as our main methods of evaluation.